balancing of redox reactions. The reason why we are doing this is to ensure the law of conservation of mass is carried out, is followed here, right? So the number of atoms of each element should be equal on both sides of the chemical equation. How are we going to do this balancing of the redox reactions? By 4 different methods. One of them is hit and trial method. The first is called as hit and trial. Like we used to solve in case of factor theorem for higher degrees, for higher order polynomials. Second one is partial equation method. And third is our oxidation method, oxidation number. So this is the one that we will be widely going over. And finally, fourth one is half equation method. Yes. It is also called ion electron method. It's also referred as ion electron method. Right. So we are going to see the last 2 methods now. Okay. Shall we take a look at it? The oxidation method, oxidation number method.
Sir.
Yes, sir.
All right. So there are 5-step approaches. This is a 5-step approach which we can write down by writing the skeleton equation, skeleton ionic equation. Step. We'll see that in a while. And then second step, in the second step, what we do is we assign the oxidation state to every element. To every element. And then balance. Balance. How do you balance? Balance the atoms except hydrogen and oxygen. Okay. This is the step. These are the steps that we are going to follow. Thirdly, find the change of the oxidation number. Look for the changes. And try to equalize it now. After that, you balance the charges, ionic charges. So we see the ionic charges on the left side, total ionic charge on the left, and see the total ionic charges on the right, and try to divide them. And the last one is when you go for balancing the hydrogen and oxygen atoms. This is the 5-step approach that we're going to carry out. Let's see the example. Potassium dichromate. Potassium dichromate with sodium sulfide. And this in an acid solution which gives chromium ion, chromium 3 ion, and sulfate ion. So this is the word equation that is given to us, right? And we need to convert it into a formula, write down the formula with the charges, whatever is given, and then balance it out. Alright?
Yes, sir.
Potassium dichromate K2 Cr2O7, right? So dichromate. So we're going to write down the what will be for dichromate then? This is +1.
Cr2O7.
This whole thing is going to have -2 because 2 into +1. So Cr2O7 2 minus solution plus sodium sulfide. What will that be? Na2SO3. So SO3 will have 2 minus, sodium will have a +1. So SO3 charge of this ion is SO3 2 minus. Do you guys understand this part?
Yes, sir.
Right? Is that clear? Okay. So this reacts to give chromium ion, and that is Cr3. It's given 3, so that is 3 plus sulfate ion SO4 2 minus. Yes, this is also going to be in aqueous form. So the first thing is writing the skeleton ionic equation, which we just now did. Alright? So we just wrote down that. Next, no need of the word equation because we have written it down. Now try to give what was the second step we saw? Assign the oxidation states to each element. And it said chromium 6, dichromate 6. Right? So what is the oxidation state for chromium going to be?
+6.
+6. Oxygen?
-2.
-2. Sulfur?
+4.
-6 is equal to x -6 is equal to -6, or x is equal to +4 in this case. So sulfur will have a +4. Oxygen is going to have a negative 2 as usual. Chromium is already has plus 3. Sulfur in this case, sulfate, what will be the thing?
Plus 6.
X minus 8 is equal to minus 2, x is equal to plus 6. Is this clear?
Yes, sir.
Second step also done. So what is the third step?
To find oxidation and reduction.
Finding the change in the oxidation numbers.
Yes, sir.
Okay. Look for the change in the oxidation number.
Chromium has been reduced.
Huh?
Sulfur is oxidized.
Chromium.
Chromium has reduced to 3 oxidations. 3 oxidation number.
So how this would have happened? By reduction,
Yes,
Yes,
sir.
sir.
By reduction.
Reduction.
reduction of
Yes, sir.
Cr2. So how many electrons are involved in this process?
Electrons, sir.
Otherwise, what is the oxidation state change here?
3.
3. So here change is 3 per atom, right? From plus 6, sorry, plus 6 to plus 3. So 6 minus 3 is 3 per atom. Isn't it? Right? We don't want to burst the crackers. Next one, is there any other change that you are observing? In oxygen, there is no
Yes,
change.
sir. Sulfur is getting oxidized.
Yes, sir.
It got oxidized. What is it?
Changes to, sir.
Change is 2,
But oxidized.
but oxidized. Shall we try balancing it now? Cr2, so this has to be 2 Cr. SO3 and sulfur, how are we going to balance them?
Multiply by 3 on both sides, sir. 3SO3, 3SO4, like that.
3SO3 and 3SO4.
Then we have to check on oxygen.
Here. Right? So is this part through? Clear now? So far?
Yes.
Yes, sir.
Okay. So now, if this part is clear, now we will move on to the next step. So here we need to balance the ionic charges. Right?
Yes, sir. Oxygen is not balanced.
So look for the charge. What is the total charge? So here ionic charge in Cr2 O72 minus is what?
-2.
Minus 2. So what is it in this case? SO32 minus
Again, -2.
Yes, minus 2.
Minus
3 into minus 2.
Minus 6.
Right? So this is minus 6. You have a minus 2, so it is minus 8 on the left side. 2Cr3 plus is what now?
Uh,
6.
-6.
3 into 2 minus is
-6.
minus 6. So this is 0.
Yes, sir.
Yes,
Right?
sir.
So minus 8 on one side and 0 on the other side. Is this balanced?
Yes, sir.
Balanced now.
No, sir. No, sir. We have to add
Sir, you
x
have
power
to add
5.
a 3 before.
Yeah, so now we have done the analysis. You've done the ionic charge thing. Now, what do you do to balance this one? So, what can be done? Is this not clear?
Yes, sir.
Right? So, we didn't do anything. We just tried to balance the ionic charge with the help of the skeleton or equation that we did. Skeleton ionic equation. So, let's rewrite it. Cr2O72 minus. We had a negative 8 overall, which gave us 2Cr3 plus 3 sulfate, right?
Yes, sir.
So this time the charge was 0. Can we add 8H
Yes, sir.
plus, right?
That side 4H2.
Plus 8 will make it 0. So I need to, what do I need to do on the right side?
Uh, plus 4H2.
We need to just bring in 4H2. Let me know if it is confusing. Because why we are doing 4H2 is to balance the hydrogen atoms. So let's not forget to put the state aqueous, aqueous, and aqueous.
Sir, SO3 is not gas, sir.
Aqueous solution of sodium sulfite. So 3 is a gas, but this is not a sulfite ion,
Oh, okay, sir.
not sulfur trioxide gas. Right. So let's see whether it is balanced now. Is it balanced now?
Yes, sir.
Chromium is balanced, sulfur is balanced, hydrogen is balanced. Let's check for oxygen. 7 plus 9, 16. And here 12 plus 4, 16. The oxygen is also balanced. So the charge is also balanced. Oxidation numbers are taken into account. And the mass, the number of elements, the atoms on the left side are also balanced. You got it now?
Yes, sir. This is an acidic medium, sir.
And this whole thing is in acidic medium. Is it clear?
Yes, sir.
Balancing of oxidation reactions. I mean, balancing of redox reactions. Clear? With the help of oxidation number method. That's the method what we are doing right now. Clear?
Yes, sir.